of the Heat Treat podcast. Today we have two guests from all the way from Pennsylvania, Andrew Orr and Jim Orr from Pen of Flame. How's it going, guys? Super excited to have you here on the podcast talking about heat treating, family business, a very successful company. Today we're going to talk about flame hardening, but also robotics and family businesses. So I would like to introduce my first guest, Andrew Orr, which was kind enough to ask James to join us as well. A lot of Jude from Andrew's side and a lot of expertise from Jim. So today we have like a perfect mix, perfect match of a very successful heat treating company. So I just would like to say hi, and if you could please, if you want to start, Andrew, to give an introduction about Pen of Flame, who you are, and then maybe you can follow up with Jim.
Sure. Thank you, Carlos. My name is Andrew Orr. I am Vice President of Pen of Flame Industries, a family-owned commercial heat treating company in Western Pennsylvania. And we have been in business since 1968. And looking forward to talking about flame hardening and robotics today.
Can you just follow up on that, just to explain a little about your background, your career?
Certainly, Carlos.
And if you could give us a little history about Pen of Flame.
Will do, Carlos. And again, thank you for the invitation. Pleasure to be here today. My name is Jim Orr. I am the company president. As Andrew mentioned, my father, his grandfather, started the business in 1968, located just outside of Pittsburgh, which was the steel capital of the world. And those aren't the cases today. Things have moved on quite a bit, and work comes from further and further away. I took over the business in 1990. My father unfortunately passed away in 92, and we've just continued to perfect flame hardening. Flame hardening has been considered a very old process. You do it in the dark and you do it in the corner. And myself and many of my associates in the flame hardening industry, we've really updated things. We've tried to make it a little bit more sophisticated. A lot of controls that are out there now, and it has its place. Flame hardening is generally thought of selective surface hardening. You instead of putting a part in a furnace and heating the entire part up, we just heat treat the selected area that needs done. And that can also be done with induction. We do a lot of larger parts are done by flame hardening, and I'm fortunate. I've been doing this for 40 years now, and the business is transferring slowly to the third generation, Andrew and his brother Michael.
So how come we don't have Michael on the call? What did he do?
Well, Michael had a little bit of surgery today, and
okay.
he was unable to, minor surgery, but he's unable to join us today.
Well, all the best. I thought he was working on the show because somebody has to get parts. Well, the other two guys are being on the interview, but fantastic. So of course, flame hardening, we would like to know a little bit more about the process. You described it really briefly. What I found it very interesting is the robotics part of it. As we spoke before the podcast, I believe there are very few commercial heat treaters, family businesses that actually invest on this type of technology, which is not cheap. And sometimes we believe, we seem to believe that it's very complex, as it is only for the captives, which I believe is not the case. So I just would like to start the interview, this podcast, with a flame hardening 101. You mentioned that it was something similar to induction. I just would like to understand and have the audience understand, since you received the part, what do you have to take in consideration, how you will handle the part, and how that part will be hardened, how, if there's a quenching involved, if there's a tempering involved, and how the robotics are made, if it's a single piece flow operation, if it's part of C2I9 or the application that is taking in place, traceability. Can you just give us a brief summary of the whole process to the audience, please?
Sure. Yeah, I'd be happy to. We do receive a variety of parts that require flame hardening. Could be anywhere from a long rail that requires one or multiple surfaces to be hardened. Also large round product like industrial wheels. Some items we're going to be spin flame hardening. Others we're going to be progressive flame hardening. And there's multiple different ways to go about it. We also can do a lot of roll product as well. They're shafts. So those will be spin progressive spin hardened. The robotics come into play more as far as taking the torch, the hand torch, out of a person's hand and putting it on a robotic arm. We've come a long way with advancements in that as well. We found that there's a lot of technology out there that can control the process even better after moving it to a robot. So what they can do with that is write a program that calls for a certain amount of process gases to come through each valve, and then constantly monitor those pressures as well. So a lot of gear teeth we surface harden using the robotic technology.
So do you just heat up the part with a flame and then you quench it? Or how is it done? Similar to induction?
It is very similar to induction in that sense. We typically will preheat each part in an oven prior to starting, and then we will make sure that it's the proper temperature before starting. And then whatever process we're doing, we're using process gases mixed together to create that highly concentrated hot flame through all of the specific tooling that we have manufactured in-house to perform that process on that part. So then in a progressive pass, what you'll do is you'll heat and you'll quench directly behind the heat.
Will you do water quenching?
Water, mostly it's a water and polymer mix though. We don't use any oils here, but it's usually a water and polymer mix.
So how will the part be handled? I mean, you will storage it on an oven, then it will go on a conveyor belt, or a robot will actually grab the part and start flaming it, and then introduce it to a quench tank, or just explain to the audience how the material handling is.
Sure, yeah, that's a good question. There's a lot of manual handling that still takes place.
Mm-hmm.
And if you're doing a long product like a rail, or maybe it's a liner for a machine, it's going to be placed on a magnet.
Okay.
And the magnet itself could either be engaged or not, depending on how thick the cross section is. Because in flame hardening, something that can come up quite a bit is distortion. So distortion of a part is a major hurdle to jump. And the magnet helps hold the part down if it's a thinner part, especially if it's long as well. So the magnet is going to hold it down, and then we're going to scan across the surface that requires hardening.
Mm-hmm. And what are most of the applications for flame hardening? Is that you're selling about rails? So it's rails, automotive, construction. What are most of the applications for the need of flame hardening?
There's going to be mining applications.
Mining, okay.
As well as material handling. So a lot of the steel mills, overhead crane wheels, and a lot of the some of the stadiums that have roofs that move, to open and close, or even the fields that roll out to get natural sunlight.
Mm-hmm.
Those products are supporting a lot of weight. Those fields, there's a ton of weight on top of that. So they all require a surface hardening process to support that. And what's nice about our process is it gives you that really strong surface, but it allows for the ductility behind it.
Right. What I'm understanding, and correct me if I'm wrong, is that you can be very selective of a big part of the place you want to actually harden the structure, right? I mean, you do it with rubber. You don't have to heat treat the whole thing, right? Which might be a big part. You can be very selective, and this is where I want to heat it up, and this is where I want to quench it. Will that be accurate to say?
That's very accurate. Yeah,
Okay.
That's what we're trying to do. When we get a part in, or we'll get a drawing in for review, and they'll typically be very specific on what surfaces they want hardened.
So have you heat treated some of those big structure for one of those big stadiums? Do you know which stadiums have your parts?
Yes, we do know that.
Is that classified, or can you share that?
Jim, you want to take this one?
I don't want to put you on the spot, guys. You know, this is going to be YouTube.
It's actually, Carlos, is something that everyone's familiar with. The Arizona Cardinals stadium.
Okay.
The field is a tray. It's a very large tray that comes outside to get sunshine because it's a natural grass field. And underneath that tray are 400 to 500 double flanged crane wheels. And the reason why you don't take the wheel and put the entire wheel in a furnace and heat it, when you quench it out, the thin flanges on these sides to keep it in line, they would be through hardened and they would break. So flame and induction could do the same thing. You harden the tread area and inside the flanges. And as Andrew mentioned earlier, it gives you ductility in the flange. So instead of the flange hitting the rail, if there was any misalignment and breaking off, which is critical on cranes, it will bend. So flame hardening is selective surface hardening of particular areas.
It's particular, yes, special areas. And how will you temper the part after being quenched?
As immediately after hardening, and the entire process in flame hardening is completely monitored by temperature, temperature controls, infrareds, cameras, everything. It immediately goes into a furnace and is held at temperature, say 350, 450 degrees for 10 hours.
Well, the whole part, not only
the entire part is
entire
tempered
part
afterwards.
Okay,
to eliminate stresses, retained austenite.
So on a nutshell, you will preheat the whole part, then you will flame harden it on a selective part of the load. If you want to say that, you will quench that selective part, and then you will temper the whole thing out.
Carlos, you're now a graduate 101 flame hardening. You've got
good. Well, if you got any spots, I'm looking for a job right now because my business is a little down, so yeah. I can work on commission. And
we are definitely looking for people. So
right, sure. No, not a problem. Always trying to help. Now, we're very familiar on the podcast with automotive. We have talked a bunch with aerospace, so we know there's CQI9 and NatCat. Is there any specifications for traceability of the parts? Because if you're holding such a big structure, how do we make sure that the part got treated correctly and with the specifications in place?
That's a good question. Not so much, we don't really play in the arena of CQI9 or those kinds of specs. However, we do have quite a bit of process control, and that's what any flame hardener could use this, or induction hardener. Jim was mentioning before the pyrometers, infrared pyrometers aimed at different areas of the part. In some cases, we even would shoot compressed air to open up a window so they have a clear view in there. A lot of products out there that will record that data, and then the data is brought into the office and stored on our server. So that's just a way of how we can have that traceability, records, ability to look back and make sure every product that went through on that machine was done properly.
Okay, now the next question will be, after we do all the heat treatment, right? And is there a lab procedure, any metallurgical checks on the spot? Do we use infrareds? Do we use hardness testers on the selected part? Because we're more used to, myself especially, to batch of the same parts. And you tested specifically in many areas, you grab a sample. How is it in your case?
Sometimes we do have a sample part that will be part of the what we receive in. Should be an accurate representation of the part we're about to harden. And that piece can be destructively tested. We usually send that out to an outside laboratory. It could be customer directed or one that we are familiar with using. I know there's a few in the area, but they can do micro hardness traverses. They can look at macro, micro photographs, anything like that to watch, looking for decarb layers and surface hardness layers and making sure full transformation occurred.
And now you have mentioned a couple of times also induction. And from where I'm learning and hearing this is that each process has its place. We tend to believe that induction is for a very big volume of parts that have to be heat treated in a specific area, and is mostly single piece flow, something similar like this. What will be the difference, or what will be the judgment to say this part is it has to go to induction, or this is flame hardening receptive? How would you that make that that balance with a customer that it's trying to define where to go?
Yeah, sometimes the drawings themselves will call that out. If it calls for induction, we typically try to route it that direction, but in some cases we don't have the capability, so we will check with them to see if they can accept flame hardening as an alternative. But we have found that induction is far better at hardening ID, like an internal hardening. I know there's some processes we did a while ago that you're trying to flame harden it, and the flame's shooting back out at you, and you can't really see the process well. Whereas induction, there isn't any flame, so you can look right in there and monitor the process.
Now let's switch to a more high-tech subject, which is robotics. So, and I would really like to have Jim just give us his feedback here. We mentioned flame hardening, so we now understand what's going on process-wise. But when was your breakthrough moment in the past when you decided to go, like, we have to put some robotics, we have to invest in high-tech here? Because the process, heat treat is a very simple process to explain. Of course, if you go deep, there's a bunch of variables and complexities that you have to take care on every single process. If you're saying FNC or flame hardening or induction carburizing, LPC, there's such a bunch of variables. But I believe you mastered that. But when was the breakthrough moment when you decided that you have to invest in robotics, and how do you did it?
Carlos, I still remember the breakthrough moment like it was yesterday, and it was about 12 years ago. We were over at the local community college doing a job fair, trying to entertain and hire some of the young kids to come to work. And a professor walked by, and he mumbled, "You should use robots." And I mumbled, "It won't work." And he took about 3 steps away, and he stopped, and he turned around. And right there, it hit both of us. We've formed a friendship. He was a professor with Robert Morris University, and he had a robot and we had a process, and he said, "Let's work together." And we spent about 1.5 years. I would go to Robert Morris, I would work with the students, and we equipped the robot with torches. And one of their individuals graduated from college, came to work for us for a few years, and it was born. And when I first brought robots into the business, I had a lot of people thinking that I really had lost it. I flipped. They're thinking this is crazy, because you have guys that would stand out there in the shop, and they would hold a torch in one hand and a cigarette in the other hand. And when's the part done? And they would say, "Well, when I'm done with the cigarette." And now the robot holds the torch. And Andrew, his brother, and a gentleman named Bert, they have perfected this. They have controlled every aspect of it. And the robot gives us repeatability that we've never had before. It takes the operator fatigue out of it. And one robot has turned into 3. And recently, about 3 years ago, we added a 4th robot. And it's the new generation of robots. It's called a collaborative robot. It's green. It feels like a Nerf football on the outside of it. You don't need any safety fencing. You put the robot in, you can work right next to it without any of the requirements of the locks and all of those things. And if you touch the robot, it stops. And the robot moves at about half the speed of a normal robot. So a lot of people think a robot's flying around. Well, flame hardening process is very slow. So the robot's actually moving very, very slow, doing the process. And when it recoils back, the robot recoils, and it's another part in and runs the part. So, and it has really helped us. It's attracted people to come to work. they looked at the old way and they said, oh my God, I'm
Oh.
cold, I'm hot, I'm wet. And now they sit there and they hold a little pendant in their hand and they press a button and say, oh, this is cool.
It is cool. It is cool. Really looking forward to go and see your shop if I'm around. It's I would love to if I'm invited, right? But
And welcome to come.
I'm assuming, Jim, that you had zero experience with robot previous to that conversation. Would that be accurate?
No.
To the conversation with the professor that you met.
I had known robots were out there. I was in many automobile plants. I've seen
Oh,
robots.
you were.
Well, I'm thinking that's
No, but-
just something that'll never work here.
Okay, so there's also the perception that robots they're very expensive, right? And the ROI will be very hard to get. Is that accurate to say it or not?
No, not
So-
there. There is a used robot market out there that is incredible.
Mhm.
And a lot of times with the old way of doing things, whether or not you're flame hardening, induction, you're welding something, there's a lot of fixturing that you get and you weld steel things together. The robot, you don't need to do that. You just need to have someone be able to program it and tell it what to do. And it follows whatever pattern you give it.
So now, Jim having this vision and starting working on robots, you, Andrew, at home, I believe you were much more younger. I believe that caught your attention, right? And you were like, this is actually pretty cool. I really want to go and work there. What was your experience with that?
Yeah, it was very neat. I know me personally, I worked in the shop, but I would run spin flame hardening machines when I was younger.
Okay.
2000 is when the first robotic arm was added, and I was in college at the time. So I got to come back, in summers and work in the shop, and I got to see, its beginnings and what it was growing into, and so everything we learned from what can we do with this thing, and just seeing us add more and more products over to that division.
Okay. Now, we have talked about flame hardening, the process itself. We talked about the implementation of robotics to a commercial heat treat shop. And the comment that Jim just gave us is like, robots are not expensive as everybody thinks, and robots are not as complex to implement. Of course, it's going to be a challenge, but if you work hard, you have the right guys, you can implement it, right? But now you have something that I believe is actually very beautiful, that you have a successful third generation family business. Can we go into that topic? Because all the happy things, but I believe there's a lot of different way of looking at things, working on things. Can you give us a little of your experience working with your father and then working with your son? That will be with both of your sons, and as well, being a third generation company. What are the challenges? But of course, what are the good things that happens? How can you optimize being a family in order to be number one in the market? Projects like this, I would really love to hear your experiences and your point of views.
Sure. Yeah. What comes to mind immediately is it's certainly a challenge. Definitely one worth doing. I was unfortunately, I didn't get a chance to work with my grandfather here, which would have been pretty cool. But I know it's been a pleasure working with my dad. He's been the best teacher I have, and he's done a great job in showing me and teaching me how he's done things, but also giving me the space to kind of learn things on my own. A little bit of help here and there, pick me up after I fall, but it's pretty good. Some of the challenges, and we've talked about this quite a bit, is business never really stops. The shop talk's always there. Dinners, family dinners, you're just find yourself talking business. So that's something we're constantly working on and trying to catch ourselves and stopping us before it gets too much.
Good. What's your experience, James?
Well, following up what Andrew said, it used to be just, Andrew and Mike and and my wife. Well, now there's ladies involved. There's the next generation, you know, there's a grandchild involved, and it's very difficult not to talk shop outside of the office.
I
And
bet.
and we really work hard on it, on not doing it. It's difficult because you're trying to balance, you know, work and play, and there's a lot of demands. So we do try to draw that line in the sand, and every once in a while, my wife will give me that look, and you know, it's okay. Shop talk's over. Let's move on.
But you know, also because it's your passion and you enjoy doing that. I mean, if you wouldn't enjoy what you were doing, I mean, you will avoid talking about that. But since I believe you guys get along really well and work really well and have built something beautiful and very successful, you know, of course, if you're having dinner and you want to talk about it, why not? But I know there's family that have no business on dinner politics. You know, every family is different.
Well, we try to have a lot
Now,
of respect, you know, for each other, and you know, just give people that space, because you can always tell we're Andrew and I are both very heavily involved in sales, and body
yes.
language will tell us that all right, it's time to back off now. Let's change subject. Let's move on.
You have like a special signal, like you touching your nose or something, like just.
Well, Carlos, when you don't have a
I
lot
do.
of hair, the head gets red real quick, and they know that Dad's bubble's about to pop.
Right. So now I believe you have done something amazing with the robotics because it's a way to attract talent, young talent, because the kids like to play with robots. And when you give them a chance to actually get some experience with robots, take a look at that, your industry becomes a little more attractive to the young talent, which is something heat treaters are struggling with because not as many guys use robots, and they have, you know, big furnaces with flames, and it's not like the cleanest environment ever, right? But do you have a bunch of guys, you know, leaning to robotics instead of going to actual heat treat? Do you see that when you have an interview and they go, going to go like, we're going to work with the robots or with the furnaces? Do they tend to lean to the robotics?
Yeah, it's interesting. Great question, because we have noticed that it is helping us attract younger talent. And one thing about the robots, especially years ago, it was kind of a misconception that it was going to eliminate jobs.
Mm-hmm.
When for us, it actually
created jobs, right?
It did, yeah. So, and we currently have some younger people working in that department, because they're so familiar with the controls. They can adapt to it. They're used to holding an Xbox controller or whatever it is, and they have a teach pendant, and they do that for their time here, and they're teaching the robot to do different maneuvers and programming it, and then when it just translates so well.
Okay, that's good to know. I mean, I believe we heat treaters should actually invest on that so we can actually attract talent. So I would like just to celebrate that you're doing that and you're being super successful, which it's obvious and it's clear, right? So Jim, I believe you've been heat treating for a long time. What are your thoughts, or what is your projection of how heat treatment is going to evolve? The industry, manufacturing. We have had this steel trade war with China. Steel is going up. Well, as well, steel is a very important part of the manufacturing, especially in the US. What are your thoughts on the future of manufacturing? Building these huge stadiums, these huge structures, or, of course, the automotive sector is big, but, mining, construction, fracking. Do you have an opinion on that?
Well, Carlos, we see some areas declining, such as mining, and then you see other areas, the entertainment industry, and that's stadiums. The amount of money that the large cities spend on new stadiums is just unbelievable. and everybody in that town, they want it all. They want the roof that opens and closes. They want to be able to attract all different venues. And so, we see growth in that area. We do a lot of work for the construction industry, and there's a lot of infrastructure going on in our country right now, rebuilding of things. And we do work for the big companies that make that equipment. So I think things shift. There's always a pendulum. It seems like a lot of it left our country, and now it seems like a lot of reshoring, people wanting to do more and more things back in the country.
That's good. I believe that's a great perspective. So I always love to ask these questions to guys with experience that have look how things have evolved, how America has started to outsource some of their stuff years back, and now how it's actually coming back. And hopefully we're going to have the next 10 years are going to be on business growth. Andrew, do you have an opinion on that? I mean, you're very young as well, but you have some windshield time already on the business. But what are your perspectives?
Well, it's like Jim was saying, it can be, some industries can be very cyclical, like the railroad industry. And we do some products for that as well. But it's really about, when one's on the downturn, usually, hopefully something else is on the up. And I'm just, as you were talking, I just I wanted to note that there are a lot of, it seems like there's a lot of heat treating companies that are expanding into Mexico as well. So I'm sure that's exciting for you to see. I know a lot of my friends work in the plastics industry, and they're making trips down to Mexico as well. So hopefully that's good for you to see also.
It is. We're trying to get a hold of that business, but it's very challenging. A lot of competition. But thanks for a heads up. Now, guys, it's been great to have had you on the show. A successful family business that has invested on heat treat, on people, on technology. James, you should feel very proud about Andrew. I believe he's doing a fantastic job. When he and I met in Florida, and I spoke to him, I believe you have done and trained well to Andrew. And Andrew, I believe you have a great mentor, a great coach, and just you're very lucky. You're a very lucky guy. Not many people have that, so that's very valuable. And
thank you, Carlos.
Just to finish the podcast, always, Andrew, you're still pretty young, but you make sure you have any advice. But I ask Jim a personal advice. If you were to start all over again and you were 20 years old and you could travel on time and actually give an advice to yourself, right, that you have learned through your entire career, what would it be?
Well, it's an interesting question because you certainly get a different perspective when you hit 60 years old. You think about life much differently. When I started in the business, I was always here. I was within the walls. You worked hard every day, and you really never got out and you never looked at the forest. You were always deep inside the woods. And about 20 years ago, I attended one of my first MTI events. Actually, it was the FNA. And all of a sudden I realized, oh my God, there's a lot of things going on out there. And we were always very protectionist. We were flame hardeners, and we weren't going to tell anybody how we did it. And we weren't going to let anyone in our shop. And after a while, I realized, no, that's not the way it's going to work. You got to work with people. And we started to work with the MTI. We started to work with some of the associate suppliers. We've worked with some of our competitors. Now some of our competitors, they don't want to talk to us at all, but that's okay. But we've talked to others. So more of an open door policy. It's not all about what you can do just for yourself. It's get a group together and make it happen. And it happens for everybody, and everybody can win. And sometimes you don't win them all, but it keeps things moving forward.
I believe that's a great advice. Well, I don't know if I understand you correctly, but also it's travel, go outside your shop and take a look at other applications, other way to do things. You meant that as well, right? Talk to people, go to shows. Is that what you were trying to say?
Yes, with me, it was, you always visited customers and you got to see customers' plants, but I wasn't really involved in our trade industry. I
Mhm.
always thought that, the MTI and things, it was all for the big furnace people and the
Mhm.
people that did carburizing. And then you start to realize that these controls that you use to control furnaces, some of them can be modified and they can be used to control our process as well.
Good. And well, also would like to talk the subject. You're very involved on the NTI. I believe that's a great institute. I've been part of it for, I believe, 5 years now. And you do meet a lot of people. You do great networking, and you're a champion of that institute. So thank you for your service, Jim.
Well,
And
thank you.
we hope to see Andrew, which I'm pretty sure we will. And it's been a ride talking to you guys. Thank you for your time. I actually did learn a lot. I do celebrate the successful business that you have built, James. Second generation, and you, Andrew, you have a big shoes to fill, which I'm pretty sure you're gonna do, right? Keep investing on technology, doing what you have been doing, and thanks so much, guys. Just would like to remind that we're uploading a weekly podcast. We're on YouTube, LinkedIn, Spotify. Andrew, Jim, help me go like this, right? We're gonna put a link. We just subscribe, right? I don't know how we're gonna do it with product, right? Give us a like, right? Is Jim and Andrew Orr all the way from Pennsylvania, Pen of Flame, experts on flame hardening. There was our episode of today. So keep posted. I'll see you next week on the Heat Treat podcast.
Carlos, thank you.